So guys, this is going to be a review about everything, guys, that we saw in the whole partial. So let's see, guys. We are going to put here as a topic, we are going to do a review. We are going to do a review of the partial, okay? We are going to do a review of the partial. Everything that you need to know to the exam. Remember, we are going to present exams next Monday. Next week, we start with the exams. So the first thing, guys, that we saw together is multiplying polynomials. Multiplying polynomials. What about if I have 2x squared plus 4 multiplying 4x minus 6x squared? What about if I have this? Well, I can see that this number here, the number 4, is multiplying with all these parentheses. Yes or no?
Yes.
So, thank you. So, we need to multiply this doing this one times this one and this one times this one, calls distributive property. So, first of all, we need to write 2x squared because he's not doing anything. So we just write it. Plus 4 times 4x. How much is 4 times 4x?
16x.
Thank you. 16x. 4 times negative 6x squared. How much is that, guys?
24.
Negative 24 x squared.
Negative 24, thank you, x squared. Now, we saw something called like terms. Like terms are numbers, or actually terms that they have the same variable with the same degree. I'm going to write it in here. Like terms are terms that has the same variable with, or the same variable at the same degree. At the same degree. So, do you see, guys, any term that has the same variable at the same degree? In our polynomial, do you see, guys, any like terms? Yes or no? Guys?
Yes.
Which one, Alondra? Which one?
2x squared and 24x squared.
Yes. Guys, look, they have the same variable, the variable x, at the same degree. The degree is 2 squared. So when we have that thing, guys, when we have like terms, we have to add or subtract just those two operations, add or subtract. But we are not gonna touch the variable, just the numbers. So we're gonna set, how much is 2 minus 24? 2 minus 24. Positive 2 minus 24. How much?
22x squared.
Thank you. The answer, it will be 22x squared. But Marlon, negative 22 or positive 22?
Negative 22.
Thank you. Negative 22x squared. Plus, we are missing the 16x. Plus 16x. Plus 16x. So we finish with the multiplication of our polynomial. But now let's talk a little bit more about what we saw in the partial. We saw something called factorizing polynomials. Yes or no? Factorizing polynomials. Do we saw that? Yes or no, guys?
Yes. Yes.
Okay. Which are the 4 methods that we saw about factorizing polynomials?
Common factor,
Polynomial perfect square.
perfect square, differences of a square, and adding and subtracting cubic.
Trinomial perfect square.
Adding and
Adding and
subtracting
subtracting
cubic.
cubic.
Common factor. I made a mistake here. Common factor, trinomial perfect square. Which is the other one?
Adding and subtracting cubics.
And the last one?
Difference of a square.
Difference of a square. Yes. So here we have our 4 methods, or yes, our 4 methods of factorizing polynomials. Okay, now pay attention for this one. Let's continue working with the same. Do you see, guys, any way to factorize that polynomial? Yes or no?
Yes.
Yes. Jose Marlon says yes. What about the other ones? Do you see any kind of way to factorize that polynomial? Yes or no? Alondra?
Yes.
Yes. Alondra is saying yes. Miguel Ángel?
I think that yes, mister.
Okay. Diego Lobo?
Yes, I think.
Cristian Guevara?
Yes.
Yes. Okay. Who says no? Who says no? David Espinal, what about you?
I think that we cannot factorize this polynomial.
Really? Okay. Let's think a little bit. Guys, what is the difference of a square? What is the difference of a square, guys? When we have a what? A binomial that is subtracting, and both terms are perfect square roots. Yes. What is an adding and subtracting cubics? A binomial when we have a cubics and they are adding or they are subtracting. What is a trinomial perfect square? Well, the name tell us. Trinomial that has perfect squares, roots. But what is a common factor, guys? Diego Lobo, what is a common factor?
When the polynomial we have two of the numbers that are alike or have a simile.
Common factor, guys, is when we have something in common. For example, I know that all of us has at least one pencil. Yes or no? Do you have a pencil with you? Yes or no? Yes, right? So
Yes.
we all have a pencil as a common factor because we all have a pencil. Well, talking with these 2 polynomials, with these 2 terms in this polynomial, what do they have in common, guys?
That they are multiples of 2.
They are multiples of 2. What about 4?
No.
No, right? They are multiples of 2. What about the variable? Do you see anything that they have in common about the
Yes,
variable?
the x.
Yes. So we can say that they have the number 2 in common and they have the variable x in common. So it is a common factor. So we put 2x, we open parentheses, and if I have negative 22x squared and I take out 2x, what I'm gonna have in the parentheses, guys? What I am gonna have in the parentheses, inside the parentheses? How much is 22 divided? Yes. Who says 11?
Me.
Christian. Yes, Christian, it's 11, guys. Remember that inside that parenthesis, we need to write a number and a variable that multiplying with the 2x gives me negative 22x squared. So which terms multiplying by 2x gives me negative 22x squared?
Negative
Negative
11x.
11.
Negative 11x. Yes, negative 11x plus which term multiplying by 2x gives me 16x?
8.
Which one?
8.
8, like this.
Yes.
So this is going to be our factorization. 2x parenthesis negative 11x plus 8. But what happened if you tell me, Mister, actually, I don't trust you. I really don't trust you. Well, I'm gonna make you trust me. We're gonna see. If we have 2x parenthesis negative 11x, if we have 2x parenthesis negative 11x plus 8, remember that if we want to verify our answer, we need to do the multiplication of the polynomial. So we're gonna do this times this and this times this. 2 times 11, negative 22. 2 times negative 11, negative 22. X times x, x squared. Plus 2x times 8, 16x. And if we have the same as in the exercise, it means we have our factorization completely correct. Let's see if we have the same. Negative 22x squared plus 16x squared. I'm sorry, plus 16x. Yes, we have the same. Negative 22x squared plus 16x. So our factorization is completely correct. Now, as you can see, guys, as you can see, in this part, in this exercise, we practice how to multiply a polynomial. We practice how to identify like terms. We practice how to factorize a polynomial, and at the end, how to verify by multiplying polynomials if our factorization is correct or not. So it was a very good exercise because we practice those things. Now, let's continue. Remember that if you have questions, let me know. Talking about polynomials. Talking about polynomials. Do you remember which are the names of the different polynomials that we have? Do you remember it?
Binomials.
Yes, we have one that is called binomial. Binomial. Yes.
Another one named trinomial.
Monomial. Yes.
And
trinomial.
And trinomial. Yes. So these ones are the kinds of polynomials that we have. Binomials, monomials, and trinomials. Now, who can give me an example of a binomial? Who can give me an example of a binomial? Who can give me an example of a binomial, guys? The example that you want.
I have one.
What?
I have one.
Tell me.
4x plus 11x.
Plus 11x. Are you sure, Marlon, that is a binomial?
I think so.
Guys, actually, if we have, for example, any change, like if we put this as an x squared, or if we add another variable like this, it can be a binomial. But why, if we leave it like that, like Marlon says, why not? Because Marlon,
Because they are common factors.
they are common factors, so they can be adding, and this it will be 15x. So, and 15x is not a binomial. So that's why your exercise is not a binomial. So, but if I change something, if I put a y in here, now we have an example of a binomial. Remember that binomials, guys, I'm gonna write it again. Binomials are polynomials that has two terms. So this it can be an example of a binomial. What about the 15x? What kind of polynomial is 15x, guys? What kind of polynomial is 15x? What kind of polynomial is 15x? Hello? Yes?
You can hear me?
Yes?
Okay.
Miguel Ángel, what kind of polynomial is 15x?
A binomial.
15x.
It's a monomial because it's alone.
Thank you, Christian. It's a monomial because only has one term, because we only have one term. So we can say it again that monomials are polynomials that only has one term. So we already know what's a binomial, what's a monomial. What about trinomials? What is a trinomial, guys? Who can give me an example of a trinomial? Who can give me an example of a trinomial? David?
4x squared minus 10x.
7 or 10?
10. Minus 20.
Minus 20. Yes, that is a perfect example of a trinomial. Yes, because we can say that trinomials are polynomials. Trinomials are polynomials that has three terms. And yes, we can see here that 4x squared is a one term. Negative 10x is another term, and the 20 is another term. So these are the kinds of polynomials that we have. But what happened, maybe you can ask, Mr. What happened, Mr., if we have a polynomial with 4 terms? What happened if we have a polynomial with 4 terms? Something like this. Mr., what happened if we have something like this? How can we call this, Mr.? A trinomial? A quadrinomial?
Polynomial.
Yes, a polynomial. When we have polynomials more than 3 terms, we just call them polynomials. They don't have any specific name. They are called just polynomials. So we can put here when we have a polynomial with more than 3 terms, we just call it polynomial. We just call it polynomial, okay? So let's continue. Remember that if you have questions, let me know. Let me know. David, tell me.
Mister, I have a question of the sum. In each exercise, we have to put which type of...
If I ask you, yes. If I don't, no.
Okay.
So let's continue, guys. Let's continue. Talking about one of the methods of factorizing polynomials, it's important to know that we have 2 formulas. Do you remember in which method do we need 2 formulas? Do you
Adding and
remember?
subtracting cubics.
Yes. When we are talking about adding and subtracting cubics, we need 2 formulas. We need 2 formulas. We are going to use one formula when we are adding. When we are going to use this formula, A plus B, open parentheses, A squared minus A times B plus B squared. Yes or no?
Yes.
Is that the formula, guys, that we have when we are adding?
Yes.
Yes. And who can gives me the formula that we have when we are subtracting?
A minus B, close parenthesis, open parenthesis, A square plus A times B plus B square and close parenthesis.
Thank you. Do you believe him, guys? Yes or no?
Yes.
Yes.
No. No. Yes. Yes.
Yes or
Yes.
no?
No. No.
No.
No.
Why not, David Espinal?
Because the then of A times B is negative.
Why?
Uh,
Why,
I'm
David?
confused, mister.
Okay.
Because
Okay, let's not get confused. Okay, if you are confused, guys, let's go to Google and let's put formulas of adding and subtracting cubics or cubes. We're gonna have here the formulas. When we are subtracting, this is the formula. Look, 8 minus b, parentheses, a squared plus ab plus b squared. And is the formula that we have. Now, what happened when we are adding? When we are adding, we have a plus b times a squared minus ab plus b squared. And we have a plus b, parentheses, a squared minus ab plus b squared. So yes, these are the formulas that we have when we are adding and when we are subtracting cubics. Now, David Espinal, understood?
yes.
Nice. Now, what happened, kids, when we are talking about roots? When we are talking about roots, let's put in here. Let's put here roots. What happened when we are talking about roots? Well, at the moment, we are working with square roots and we are working with cubic roots. What happened, guys? What happened if I give you, for example, this root? What is this root? An square root or a cubic root? What do you believe is this root when we don't have any number in here?
Square root.
Yes, it's going to be an square root. So we can say, we can add a new comment in here. When we don't have any number in the root, we already know it's an square root. When we don't have any number, we already know it's an square root. What happened, guys, if in the exam I tell you the cubic root of 10, 9 is the same as if we have 10, 3, 10 elevated at 3, 10 elevated at 3. What happened if in the exam I ask you, is this expression true or false?
It's true.
What do you believe? David Espinal is saying that it's true. What about the other ones? What do you believe, guys? Is 10 elevated at 9 the same that if we have 3 10s, all of them elevated at 3? Is the same? Yes or no? Marlon?
I think that it's correct.
Okay, let's see. How many terms do we have in this, in here? How many terms?
1.
1 term. Remember, what means something
9.
elevated?
9.
If we have, for example, 10 elevated at square is the same that if we have 10 2 times, 10 times 10. And 10 times 10 is going to be 100, right? Yes or no? So
yes.
If we have 10 elevated at 9 is the same that multiplying 9 times the 10. 10 times 10 times 10 times 10 times 10 times 10. So we have 9 terms. In here, in this first one, how many terms do we have in here?
3.
3. And in here, how many terms?
3.
3. And in here, how many terms?
3.
And if we are multiplying, what happened with the exponents when we are multiplying? What happened with the exponents when we are multiplying, guys?
We add them.
We add them. And how much is 3 plus 3 plus 3?
9.
Is 9. So yes, having this is the same as having this. And now, if I want to know which is the square root, the cubic root, sorry, of 10 elevated at 9, we remember that we can cancel this 3 with this one and with this one and with this one. And we're gonna have just the 10. And how many terms do we have in here? 1, 2, and 3. So the cubic root of 10 elevated at 9, it's going to be 10 cubic. Understood? Yes or no?
Yes.
What about the other ones?
Yes.
Yes.
Alondra?
Yes.
Everything clear, Alondra, as water?
Yes, clear as water.
Sara? Sara Cáceres? Is everything clear, Sara Cáceres? Yes or no? Sara?
Yes, mister.
Carlos Casco, is everything clear, Carlos?
Yeah, I understand everything.
Okay, Christian Guevara, is everything clear?
Yes.
Okay, kids. So that is going to be our little review about actually everything that is important for the exam. Remember, guys, to keep studying. Remember that if you have questions, you can write me and I will help you. Remember to see videos. I will upload this video for you, and you have more videos, guys. Remember that in my channel, we have videos about factorizing polynomials and multiplying polynomials and a lot of videos about math. So if you want to see them, go ahead. Guys, it was my pleasure to be your teacher in this partial. It was nice to meet you, all of you guys, instead of being in the school, but it was my pleasure to be with you guys. I hope all of you do a great work next Monday in the exam. So it was my pleasure, kids. Remember always to keep working, okay? Always keep working in everything. Don't give up, guys. You can do whatever you want to do. So this is going to be everything for me, guys. Thank you for everything. Thank you and good luck in the exam, guys. Goodbye to all of you. Goodbye, kids. Goodbye.
Bye,
Mr.
Bye, mister.
See you, mister.
Bye. See
See
you.
you, Mr. Bye.
Goodbye,
Take care,
kids.
mister.
Bye, Mr.
Bye. You too, guys. Take care.
See ya.
Goodbye.
Bye, mister.
Goodbye. Goodbye, David.